C interfaces or Thunderbolt. You can run either over the thing. It's like a little workstation, except that it's this big, right? And you need an external screen. Now, it may be surprising that like they put my name on it. It was custom configured for me. That might be a supply chain issue if somebody wants to put special software on yours. Every time you boot a Mac, the first time it asks you where you are, and it also has full, I don't have that screen, but it has support built into it for something like 60 different languages. So whereas Microsoft sells language packs for Windows, every version of Mac OS X has support for every language that they have internationalization for. And it's actually easy to add your own languages. Well, it's possible to add your own languages without being a developer. But you tell it where you are, and then it asks you if you want to enable location services. And it says location services allow apps like maps and services like Spotlight Suggestion to gather and use data, including your approximate location. So they give you the option of using location services, and then when they're used, this little icon appears in the command bar, just like it does on an iPhone. And the way location services work is the computer has Wi-Fi built into it, and it listens for nearby 8 to 11 broadcasters, and it takes a few of the MAC addresses that it hears, it sends them to a service, and it gets back the GPS coordinates. And it's pretty accurate. It's pretty accurate. They don't do it by geolocation on the IP address, because that's not accurate. They do it with the Wi-Fi. Apple has a big database now of Wi-Fi locations to geolocations, just like Google does. There are 2 or 3 of those services out there. Then it gives you the option of having analytics report back to Apple, just like your cell phone might. You can share Mac analytics with Apple, and you can share crash data with app developers. So when an app crashes, it actually creates a crash report. And typically that crash report stays on the hard drive, but it could optionally be sent to the app developer. So you can look on the hard drive and see what apps have been crashing, which is kind of useful, right? But it's also kind of revealing, because there's additional information that's included there, like what the person was doing. But this is, Apple has this commitment to privacy. They're going to make sure that you're informed, and you can turn it on and turn it off. And then there's Siri, which is their assistant. It doesn't work as well on the desktop as it does on the phone. That's a choice to make people buy phones. It could be exactly the same, but you can enable it. It doesn't do much now. And then they're going to ask you, hey, do you want to put all your files in iCloud? So iCloud is like Dropbox. It copies the files off your local computer to the Apple iCloud. It will sync it to other devices. It doesn't always keep the whole file on your computer. If you don't have enough storage space, it will take the bigger files, and it will leave behind very tiny files that when you click on them, it causes the file to download. It remembers which files you're using and which files you're not using. And so one of the nice things about the iCloud is it allows people to buy MacBook Airs that have 128 gig of storage, and then to use 500 gig of files, and not even think about what they're doing. It's just completely integrated. This means that there's potentially a lot of their data in iCloud, and if you can get access to their iCloud, you can get access to more data. Of course, you can get access to iCloud through legal means, like serving Apple with a warrant, because the iCloud data, the files are not encrypted. So on the desktop, we even have more features that we can integrate. Wi-Fi calling. So Wi-Fi calling is, I have an iPhone, and my iPhone's upstairs and I'm downstairs, and my phone rings, and I can take it on my desktop. It turns the desktop into a speaker microphone. That's kind of cool. But it also means that the desktop knows a lot about the phone, and the phone knows a lot about the desktop. So Apple's moving data between all the devices in the same iCloud account. And it's pervasive. So like if you search for files in Safari on your iPhone, they'll show up in history on your desktop, which is kind of cool if you are going after bad guys, but it's not cool if you're into privacy. It automatically synchronizes contacts. And it can even synchronize internet accounts between the various machines. So they're really trying to create this seamless integrated environment, and all the sensitive information is stored in keychain. So they have a security model, they have a privacy model, and they have a user services model. So Apple, back in the early 2000s, they realized that people weren't backing up their computers. They prided themselves on usability. They created this thing called Time Machine. You basically slap a big external hard drive on your computer, and it says, hey, you just put a big hard drive on the computer. Do you want to use it for backup? And people say, well, yeah. And so then what it does is every hour it copies all of your files onto the hard drive, right? The first time, but then it only copies the files that have changed. And the way it does it is it creates a directory for every hour, and it uses hard links on the hard drive, so it doesn't take extra space to store the same the same file multiple times. If you make a change, it doesn't use a hard link, it puts out another copy. After you store like a day's worth by the hour, then it just stores every day, and then it stores like once a week, and then it starts to expire out old ones. And it's all completely automatic, and there's a user interface for recovering files. So it's really cool if you're doing forensics. You grab their Time Machine drive, and now you have like the past. It will ask you to encrypt the Time Machine drive. It will warn you if it's not encrypted. It encrypts it with AES 256. The encryption key is a passphrase, and the passphrase is stored in the local keychain. But you can crack it, again, using John the Ripper with 2 tries per second. Backups don't need to be restored to be analyzed forensically. You can just analyze them directly. One forensics tool out there, Blacklight, is aware of Time Machine. So if you have the same file 100 times there, it won't show it to you 100 times. It'll show it to you once. But other forensic tools are not aware of Time Machine, and they'll show you 100 copies. Any questions at this point? So I've gone over like some of the forensic opportunities. Yeah?
Does the browser history across your Apple devices, does that only work for Safari or Chrome also?
That only works for Safari. So I am going way too fast, so questions are good. With Chrome, you have a different company supplying software with a different funding recovery model. So if you use Chrome, Google's going to tell you to log in, because more features will be available if you log in. And one of those features is it gives you integrated browser history across every version of Chrome that you've logged into. And you can go to Google's website and review your browser history. You can delete things selectively from your Google browser history. You can do that on Safari also. Like on both of them, you can say, oh my gosh, I don't want to tell people what I've been doing on the computer for the last hour. And so they now allow you to delete the last hour of history, rather than like all of your history or nothing, which kind of is ridiculous. So if you're using Google Chrome, hopefully you're protecting your Google account with 2-factor. And Apple does not have 2-factor for protecting your Mac, because it just has a password to log into the Mac. But they do support 2-factor for protecting your apple.com, your iCloud account. And one of the things you can do is you can say, I want to be able to log into my Mac using my iCloud account. I don't want to manage separate passwords. And then you'll get the 2-factor to protect your Mac, but it also means you can reset your password from the cloud, which is really cool, right? So, or you can reset somebody else's password from the cloud. And these machines support multiple users. So you can have one machine that's shared between multiple users, and they can all have their own accounts. Any other questions there? So, yeah.
Oh, like a good teacher, you're making this seem easy, like
It is
an
easy.
athlete.
There's just a lot.
Well, my question is, what is it that's giving law enforcement such heartburn about Apple?
Well, we'll get to that.
Okay.
We'll get to that. That's the Mac forensic challenges. Right, so, yeah. So there's my Apple again that I got, and if we go through these screens again, they talk about data and privacy. You won't see this with every feature, since Apple, okay, I'm sorry. data and privacy. This icon appears when an Apple, and these are like literally captured off the screen with a digital camera. This icon appears when an Apple feature asks to use your personal information. You won't see this feature with every feature, since Apple collects this information only when needed to enable features, secure our services, or personalize your experience. Apple believes privacy is a fundamental human right, so every Apple product is designed to minimize the collection and use of your data, use on-device processing whenever possible, and provide transparency and control over your information. And that's what law enforcement is really upset about. Apple is going out of its way to make sure that no personal information that's sensitive is not stored in a keychain. Apple is going out of its way to make sure that the encryption is properly implemented everywhere. And on the phones, they're going, well, actually on my machine too, and I'll get into that, they're going out of their way to make sure you can't take that hard drive and move it onto a cracking service and try to crack it in parallel. So you can do that with my external drive, but you can't do that with my internal drive. And then if you have a strong password on the external drive, then that's pretty good too. So there's that text that I just read to you. So they have integrated two-factor in all of their apps. And it's a good two-factor. Like, it isn't just that you carry around a little secure ID thing and type in a second code. I go to apple.com and it wants to authenticate my browser. It doesn't give me a chance to say, no, don't use the two-factor. It pops this up on every other one of my Apple devices saying somebody's trying to log into your account. Here's where they're located. And do you want to allow that or not? And if you say, yeah, I want to allow it, then it gives you a 6-digit code on that device and you have to type it into the other device. So one of the reasons I suspect that law enforcement might not like Apple's two-factor implementation is it's very hard to do surreptitiously. Like somebody tried to log into my Apple account from somewhere in Asia a little while ago, and I'm like, oh gosh, that's really bad. I changed my password. So in the old days, we would tell people, if you see somebody's phone, put it in one of these Faraday cages, put it in a bag so that they can't send it a kill code. Oh, Apple, I don't have slides on this, but iCloud supports remote kill on every device. So you can remote kill a Mac, and it does it by deleting the encryption key. You can remote kill every iPhone, as long as it's signed into iCloud. You can track the physical location of all your devices. All those MDM features, mobile device management, that corporations have is available for free to anybody who has Apple equipment. It's built into iCloud. So you can figure out where all your devices are. You can kill them. You can see when they were last accessed, when they last logged in. So that's a problem for people who want surreptitious access to data. System integrity protection. So remember a while ago I said if you want to use dtrace, you have to be sure to have system integrity protection turned off. Well, this is sometimes called rootless operation. I guess I have slides on dtrace, so I explained what dtrace was. So dtrace is this system, I'll go through the slides by time. It was developed by Sun for Solaris. It basically, you write your trace system, like tell me any process that touches this file, record all of its I/O activity, or record all of its TCP connections in this other file. So it's really useful for debugging system services. It's also really useful for understanding malware. It was developed in 2004, published at a Usenix security conference. 3 years later, Apple ported it to macOS 10.5, and they ship programs to use dtrace with every single Apple machine out there, right? So it's actually available on the phones too. It's been ported to Linux, and it's going to be released by Microsoft in Windows 10. So it requires root privileges, system administrator. But even then, many of the scripts won't work unless system integrity protection the scripts won't work if SIP is enabled. You have to disable it, and you have to disable it by going into single user mode. So system integrity protection is called rootless operation, and it basically doesn't allow the super user to do anything that the super user wants. It's additional restrictions on the super user. And it's a really effective tool for making malware less powerful. And it's a really protective tool for protecting your kernel. And it's a good tool for, well, let me give you an example. So like I write apps that I want to run over my mail. And when Apple brought out the newest version of the operating system, I ran my app and it couldn't access files in my mail folder because the terminal application and any program launched from terminal is now denied access to mail and contacts and photos by default. This means that like if you download an app, malware, with Safari and double click on it, it can't go through all of your contacts and upload them to China. If you want it to have access to your contacts, you have to explicitly give it access to that, even if it's running as you and you own your contacts, even if it's running as root. So this is just restrictions that are being built into the file system, and it's done with a permissions model, capabilities model. The application process has to have a specific capability to get access to these specific data sets. It doesn't need to go through the API. It can't access the files on the disk. So if you're in the business of writing malware, that makes it harder to write malware for the Mac. You can still do it, but you got to be better, which means, you know, why are you writing for the Mac? It's such a small service, so such a small market, unless you're doing these targeted attacks. So the T2 chip and pervasive encryption is another thing that law enforcement is concerned about. This is kind of like the San Bernardino iPhone that you've heard about. So one of the things that they will tell you is that your data is safe. The Apple T2 security chip gives your Mac Mini a higher than ever level of security. Your data is encrypted with keys tied specifically to your computer, and secure boot ensures that only legitimate macOS software loads at startup. So you can't boot a hostile kernel and use the T2 chip because the hardware won't allow it to boot a hostile kernel. You can't take the SSD out and look at it on another machine because every sector on that SSD is encrypted, and one of the encryption keys is built into the machine's hardware. It's actually built in, the T2 chip is the disk controller. So when it writes to the disk, it encrypts. When it reads from the disk, it decrypts. It doesn't just use that key. I can explain it. I don't have the slides. It doesn't just use that key, but it entangles that key with the user's password. Yes?
So what happens if your motherboard fries and you need to read your disk?
If your motherboard fries and you need to read the disk, you better have a backup.
Fair enough.
Okay? Yeah, you're absolutely right. You cannot move that SSD to another machine. You can use the SSD, and if you have a nice $1,000 SSD, you can use the hardware, you better have a backup. But of course you should have a backup anyway, right? And it's so easy with Time Machine. So if you have the T2 chip and you don't know the user's password and you try it 40 times, it zeroizes. So you only get so many bytes. And the same in the phone. So they zeroize after I think 10 tries.
And that's by default?
That's by policy.
So you can't configure it to not do that?
I think there's an option, but it's on by default. So on the Mac, you have to enable file. So on the desktop, you have to enable File Vault. So by but it turns out that the chip is always encrypting. Before you enable File Vault, it's simply encrypting with like a null password. And then when you enable File Vault, it re-encrypts using this different password. And then, I have slides on this later, but we can mention it now. Apple's new file system, APFS, is actually encryption aware. So if you're on NT or if you're on an old version of Mac OS or on Linux, you have an encrypted partition. And that's done by the encryption layer, and the file system sits above the encryption layer. And once you get the key to the file system, you're golden. Yeah, but on new Macs running APFS, every file has its own encryption key. And when so cracking it's much harder. when you delete the file, if it's on SSD, it tells the SSD, oh, those blocks can be trimmed, they can be erased. But the encryption key is kept in the directory entry, and when the directory entry gets overwritten, there's no way to recover the file, even if it hasn't been overwritten, even if it hasn't been trimmed. It's just gone. If they implemented the crypto right? But they have some very good cryptographers at Apple. You look confused.
Oh, I'm just conceptualizing.
Yeah.
I'm comparing that to the way that Windows deletes a file where it just kind of truncates the name and it's still there.
Yeah.
So instead of just truncating the name, it's actually deleting the key and
Yeah.
truncating the name. So even if it gets overwritten, kind of like that.
Right, and
Yeah.
Windows 10 is also trim aware, so if you have a big file and you delete it, the sectors can be erased if it's on an SSD, but on this machine it's gone much faster. There's some other things that the new APFS offers. It offers copy on write. So if you have a 50 gigabyte video file and you want 3 copies of it, you can copy and paste it twice and do that within a second. Now you have 3 copies of it, and it doesn't take any more disk space because they're all copy on write. If you start modifying one of them, the sectors that you modify get written somewhere else. And only the sectors that you modify get written somewhere else. So it doesn't copy the whole file, it does it block by block. It allows you to get much more, much better use of that SSD. So it's a modern file system. The old high-performance file system, HFS, was 30 years old, so it's time to have a new file system. Windows is bringing out a new file system, but they've had some problems getting it deployed. So the Apple system has full support for email encryption out of the box. Just like Outlook has full support for S-MIME, but nobody uses it, Mac OS X Apple Mail has full support for S-MIME, but nobody uses it. If you receive a digitally signed message, it will verify it for you. And if you give it a private key, then it will give you the option of encrypting and signing all of your outgoing messages. There's also a PGP plugin, which Outlook doesn't have, so you can get a free PGP plugin and then send and exchange PGP mail. But it's a better implementation than Windows because like when searching all mailboxes include results from encrypted messages, yes or no. So if you check that, it will put the words from the encrypted message in the index, the search index, which has to be unencrypted. But if you don't check that, then the encrypted mail that you receive won't get indexed, so it's more secure. It's a trade-off. And you're still storing it on an encrypted file system, but this is like the additional layer of message encryption. So in general, they're more concerned about getting the encryption implementations correct than Microsoft seems to be, which is great if you're a user, but it's bad if you are trying to do forensics on this thing. So if you download the slides, you'll find this link to the Black Bag. They're a company that makes, yes sir?
Is now the time to ask about what about benevolent surveillance?
Benevolent surveillance.
i.e. device management? Or are you going to get to that?
What do you mean by that?
Well, so say you're a company or you're government or something like that, you issue a bunch of Macs to your users, and you want to you want them to have external privacy. You don't want your competitors and your adversaries to get access to the data on them, but you yourself want to be able to see everything that's on it.
So we call that device management.
Right.
And like Windows, there's complete support for device management in a corporate environment. You can define policies that allow any control on any application to be enabled or disabled. Unlike Windows, all of the user interfaces that come up on every Apple app is generated by an underlying API that's object-oriented. So every one of these things can be identified, and you can create a policy to turn on and off to enable or disable any control. You can pre-configure them. The mobile device management, it integrates with Marikai, it integrates a bunch of others. So I have all my machines under MDM, and I can follow them around. And that's completely appropriate for a commercial machine. So the disk encryption is also integrated with the MDM. There's an enterprise recovery key, so that if an employee has an encrypted Mac and they get hit by a car, you can recover their hard drive. without their password, because there's an enterprise recovery key. So yeah, they got that right. You can't recover their keychain. So you can't impersonate the user, but you can get back their files, which is probably the correct thing. So I mentioned about APFS. This goes into it a little bit deeper. It's an advanced file system that supports files up to 263 bytes, 64-bit file IDs, 1 nanosecond time granularity on timestamps, copy on write, as I mentioned, native encryption with per-file encryption keys, and transparent support for the SSD flash. It erases files after you delete them. That's a background process. So if you have flash, whereas normal magnetic drives, it's like you can write a sector any number of times, and then you can read it any number of times. With SSDs, or with flash, you have to erase it, and then you can write it, and then you can read it. The erase blocks are larger than the write blocks. You erase it by page, you write it by blocks. And there's also a limit to how many times each page can be erased and rewritten. And so that sort of management makes SSDs a little bit more difficult to work with, but that's handled transparently in APFS for you. So where do you find this APFS thing? Well, all new Apple devices have it by default, the iPhones and the desktops. All Mac OS, iOS devices running the current operating system were transparently upgraded in the field. So like a few years ago, Apple shipped out a new phone release, and they turned everybody's phone file system from HFS Plus to APFS. And then a year later, they did that to everybody's desktop computer. And that takes a lot of guts. But to do a file system upgrade in the field with no backups on anybody's drives. But the backup process was also designed that if it was interrupted, the original HFS file system was still intact. So it built the APFS file system and pointed all the data to the old files. External drives were not automatically upgraded by macOS, and that was a policy decision because you might be plugging it into an older machine that didn't understand APFS. So Apple also has these things, since they control both the hardware and the software, they can play games like this Fusion drive, which has some SSD on it and then some hard drive on it. The SSD can be 24 gig to 128 gig, and the hard drive can be 1 to 3 terabytes. This sort of gives you the performance of an SSD, but the storage of an HD, which is kind of cool. It's managed by the operating system, not by the firmware. So if you're doing forensic analysis on it, it looks like 2 drives, and it can be a little bit difficult to analyze. These are probably going away just because it's difficult to get all the software working. There have been some reliability issues. But they're out there in the field, and so if you're going to grab somebody's machine, they might be running one of these, and you need to be aware of that. So I'm going to talk about logging. So if you do forensics, logging is a lot of the action. They give you pattern of life, it tells you what the apps have done. Apple has a unified logging system that replaces the traditional text-based Unix log files. This was released a few years ago with OS X 10.11. Traditional logging is text files stored in var log, and there's the syslog facility that listens on a TCP and a UDP port and puts things into the log. And there's a program called new syslog that does log rotation, and there's configuration stored, right? And if you type man syslog, it tells you that this is a program that goes back to FreeBSD 2.2, and Ted So wrote it in 1987 when he worked for Project Athena, and I worked in the same office that he did, but he went to Red Hat. And Bugs does not yet automatically read the logs to find security breaches, so Ted has a great sense of humor. They introduced this unified logging in 2014, and the idea was log files are designed to be written and not read, right? They're really hard to use for debugging. They're designed for the original user, the original programmer. So Apple said, well, let's actually build a logging system that's useful for everybody. So first of all, it was designed to be efficient. It stores data compressed. it defers work. So it actually knows the difference between storing messages in memory and writing them out to the drive. And it stores more detailed information in memory and less detailed information on the drive. And if you're debugging, you debug with the memory-based logs, and then if you're trying to do recovery after the fact, it's looking at the disk-based logs. So you know what's coming up. The sensitive information is never written out to disk, only kept in memory. The logs by design are not supposed to have PII in them, which means they're not supposed to have usernames in them, they're not supposed to have subject lines of email addresses, they're not supposed to have to and froms. That's supposed to all be gone with the new unified logging system. What's more, the APIs decide what is private information. By default, they will write out your quoted strings, but they won't write out your substituted variables into the quoted strings. Here's the architecture. This was put out. So multiple processes, and they're writing to a compressor program, and then this is the diagnostics daemon, and this is for live log streaming. This gets all the data, but then for data that gets written to the drive, it gets compressed. It's in this compressed buffer, and then some of that gets kept in memory, and some of that gets put out to the log files. And it actually has separate log files for regular data, faults and errors, and other things. So you might want to keep the faults and errors longer than others. So this is all available online. You can read the documentation. There's an hour-long video presentation. It's bad news for forensics investigators, though. As I said, the NSLog function automatically looks at the arguments, and it doesn't log the sensitive arguments to the disk. They have good documentation, and it's on every machine out there. You don't have to go to the internet. You just type man log, and it tells you about it. Unfortunately, the documentation is incomplete. So, for example, you'll find these files in the log directory, but it's not at all clear how to read them. Somewhere it tells you that syslog-f will read them. And then the first thing it tells you is most system logs have moved to a new logging system. See log 1 for more information, and then it gives you some of the log information. But you can't just use grep on these log files anymore. You have to use syslog-f. And these things are super compressed. They expand like 50 to 1, 100 to 1. I checked on my Mac, and something like, do I have the figures here? No, maybe I don't. No, I don't have the figures here. But I had like 50 megabytes of log files on the hard drive, and it expanded to 6 gigabytes of text log data. So here's an example of the impact of private versus public. And this is one of Apple's examples. So you might have a log function that says user percent greater than public @ logged in, user @ private logged in. So here we're actually defining whether you can override the guessing. And if you view it in the debugging tool, Xcode, it will show you the variables, but